Just a few more things this week that we need to discuss. We're going to be talking about, again, kind of data. So when we display data, we often get our results in decimals, right? And some students have difficulties in rounding. So just a couple of rules for rounding numbers. If your data set is to the 10th place, just one number past the decimal point, then your final answer, take it out just one more place and then round it off. We run into trouble when we round at each step in our calculations. When we're figuring out standard deviation, for example, and we're doing it manually, we will have several columns of numbers. And if every time we go through and do our process, we round that number, by the time we get to the last calculation, that number can be quite different. So save all of that rounding. Your calculator will hold that information. You can have it out to 4 decimal places is usually what I suggest throughout the whole calculation. Then at the end, round that final number to make it meaningful to us. I don't think that it's necessary for, if you have a fraction, to change that to a decimal unless it asks for a decimal approximation. Remember, a fraction is always going to be more accurate than a decimal unless it is a fraction like 1/2, which that means the decimal 0.5 exactly. But very few times do we have it mean the decimal exactly. Usually it is a decimal approximation. Students often are confused about that and think that the decimal is the way to go because that's what the calculator gives them. But keep it in fraction if it's given in fractions. This is kind of like talking about the different types of data, but this is how we classify these types of data, and this is levels of measurement. We need to determine what level of measurement the data is that we're working with so that we can know what type of statistical tests and calculations we can do. Data can be classified into 4 levels of measurement, and they are listed on the screen: nominal, ordinal, interval, and ratio. And just like it sounds, the first one, nominal, we're just naming. We're just naming something. So it could be blue, green, purple, and orange. It's going to be mostly qualitative data, not quantitative data. And it doesn't really matter what the order is, right? Nominal scale data is not ordered. I can't say that blue is better than red unless it happens to be your favorite color. So there is no better than. Color of eyes, not better than. Even political parties, not better than. This is just naming the data. So that one's pretty easy to talk about. I think the example in front of you talks about putting things on top of a pizza, or actually putting vegan pizza, veggie pizza, and vegan sushi first or second. It doesn't matter, right? Those kind of things, there's no order to them. We get into order when we talk about ordinal. Ordinal is about order. It's going to be similar to nominal data because it is going to still be our qualitative data, but it can be ordered. Good, better, best. Yeah, I can put those in an order, right? The top 5 national parks, I can rank them from 1 to 5. You can't measure the difference between the data. You know, one has the most visitors and one has the least visitors, but the most visitors doesn't have 5 times as much or a measurable amount more necessarily. So even though there might be some numbers involved, it is just an order. One that I think that makes sense sometimes to students is ranks in the Army, things like that. Freshman, sophomore, junior, senior, that would be ordinal. There is some sort of measurement to it, but not one that is meaningful. The next scale, then we start talking about our interval scale. Interval and ratio are the next 2, and they are both talking about numbers. And they are both a little bit confusing to not get them mixed up. So an interval scale, it can be measured, and we can put it in an order. So if we talk about temperature scales, they're measured by using the interval scale. And temperature measurements, 40 is equal to 100 minus 60. Differences make sense. But 0 degrees does not make sense if we're talking about the 2 different scales. It's not the absolute lowest temperature. There are, minus 10 degrees, minus 15 degrees that are colder. So interval scale is, if you notice this little chart here, is 5 degrees 5 times colder than 1 degree? No. Determine if one data value is a multiple of another. No, for our interval. And there is a measured interval, 1 degree, 2 degrees, 3 degrees, but that 0 point isn't meaningful because 0 degrees doesn't mean the absence of temperature, and nor is it a multiple. So that is our interval, and I think that that's a good example to go back to, that and ratio. Ratio is actually what most of our numbers are. Ratio scale is like interval, but it has a 0 point. 0 means the absence of that quality that we're looking at. One more type of data here is dress size. Women have a dress size of 0, 2, 4. A 0 does not mean that that woman does not have a dress size. That is an actual size of 0, right? And size 4 is not twice as big as size 2. So that does not have a meaningful 0, nor does that scale mean a multiple. So that again would be that interval data. Where ratio data is 0 means absence of that quality, and 20 is twice as much as 10. So it has interval that is important, it has a data point that is important. Differences have meaning. So that's the ratio scale, and that is the highest, and we can do the most calculations statistically with that scale. We're going to talk about collecting data now, and just a touch about what we do with it. We're just going to talk about frequency tables. So let's say we ask a question. I think the data in front of you, 20 students were asked how many hours they worked, and they worked 5, 6, 3, 3, 2, 4, all sorts of numbers, right? And then we want to gather that data into something that is meaningful to look at instead of just a string of numbers. So we put these numbers there. Let me get a pencil. These numbers right here, and we are going to take them and see how many times we had each number. So the data value of 2, well, if you look at our data, that happened 3 times. The data value of 3 happened 5 times, and so forth. Data value of 7 happened only once. So we start here developing this frequency table, very first part of organizing our data. From that frequency table, we then are going to move my face out of the way. Okay. We have the same frequency table that we had before, right? This whole area here is still the frequency table we had before, but now we have this new column here of relative frequency. Our relative frequencies come from doing a division. So we have, for this first one, 3 out of 20. Now where do we get the 3? Well, that is our frequency. That's how many people work 2 hours. Where do we get the 20? 20 is our total. So we have these relative frequencies, which then give us our percentages, our decimals or our percentages, to come up with what percentage worked for 3 hours. Well, we have that right there, or 2 hours or whatever. So we can figure out our percentages. We can add an additional column. This is kind of something that is used in statistics a lot. It's the column method. You start off with one column of data, you do manipulate it, then you manipulate it again. It's a good way to keep track, and most students that use the columns are successful. Does that mean that most students that do not are not successful? Probably. I just decided to spin it with the positive spin on it. But yes, I suggest that you do use it just like it's going to be in the book. I'm going to move my face down just for a little bit. I don't have to move it over here. Okay. So we already have had these first 2 columns, our data value and our frequency and our relative frequency. We know how to do those. This last one here, this cumulative relative frequency, we start off with this being equal. So we start off at 0.15. That's what the percentage is that had 2 hours of work. And then we calculate the next one, but we're going to add it to the point. We're going to add our 0.25 to 0.15. And that's where we end up with this 0.40. So by the end, we're going to end up with a whole number, meaning 100%. This is useful so we know where our halfway, where we tipped into coming our halfway. I don't know if that is significant with this type of data, but we know that, okay, right here was the middle of our data set, because we have 55% now that are under us and 45% that would be over us. So that's around the middle of our data. And so looking at the hours, we can say that 4 hours seems to be the median number. So it's just another way to put it in perspective, what those numbers mean. And that is what statistics is all about, is helping us to decipher what these numbers are doing for us. Once we have that cumulative frequency, we can do some totals. And our frequencies, total number of hours, our frequency totals are always going to be equal to 100%, and that's where we end up. So here we just have some different data. Heights in inches of some soccer players. So here's their heights, how often that happened, and here we put it into a frequency table with a cumulative frequency at the end. Hopefully you can see that this might be getting exciting, but anyway, or at least you understand what it is we're talking about.